All right, so we're going to go ahead and finish up this first section on angles and measures. So the first new thing from this section that we're going to be looking at is arc length. So specifically what arc length is it is a part of a circle that we are going to be working with. So the first thing that we need to define is central angle. So a central angle is an angle whose endpoints are on a circle and whose vertex is the center of the circle. So if I'm looking at this circle up in the right-hand corner, I can tell that I'm going to be working with a central angle because I have two radii here, and then they meet at this vertex, and this vertex is in fact the center of that circle. So that is a central angle. So to calculate the arc length, so what the arc length is it's what I'm drawing in orange. That is what an arc length is. It is a piece of the circumference of a circle. So to find that arc length, given my central angle and my radius, the formula is right here. It is S equals R times theta, where S is my arc length, R stands for the radius of my circle, and theta is my central angle. The specific part that I want to make sure that everybody gets is that theta has to be measured in radians. So sometimes, actually most of the time, you will be given a circle that is, or a central angle that's given to you in degrees. You have to convert this to radians. So the steps to solve for an arc length, the first step is to make sure your angle is in radians, not degrees, and always convert it. Then what you need to do is go ahead and plug in the radius of your circle and the central angle measure. Again, make sure it's in radians. And then just with your formula, that will give you your arc length. And instead of leaving it as an exact answer with pi, what we're going to do instead is round it to the nearest tenth. So we're going to take it one step further and multiply that out times pi, and then we will be rounding that number to the nearest tenth. So let's go ahead and take a look at an example. So I'm working with this circle here, so I know that the radius is given to me. The radius is 12 inches. So let's write my formula. My formula to calculate my arc length is S equals R times theta. So I know that my radius is 12, and my theta is 45 degrees. So this is in degrees, it's not in radians, so my first step, like I know, is I have to convert this to radians. So to remember to convert to radians, I have my degree measure and I multiply it by pi over 180. So that then gets me 45 pi over 180, which when I reduce gets me pi over 4, because 45 divided by 180 is the same thing as 1 over 4. So I now have my angle in radian measure. So I'm going to go ahead to my second step. My second step is just to go ahead and plug everything in to the formula. So plugging into S equals R times theta. S is my arc length, that's what I'm solving for. My radius is 12 inches. You can just do 12. And then my central angle in radians is pi over 4. So I get that S equals 12 pi over 4. Then my last step, calculate and reduce. So 12 over 4 reduces to 3. So I have 3 pi. And so 3 times pi, when I decide to round that, I get that that is approximately 9.4. So that arc length, what I'm solving for, S, is approximately 9.4 inches. Okay, the other thing that we're going to be doing in this section is finding the area of sectors of a circle. So when I'm talking about a sector of a circle is the portion of a circle that's enclosed by 2 of its radii and an arc. So we were just working and looking at arc length. So arc length is just this piece of the circumference here of the circle. The difference between a sector of a circle and arc length is that I actually have arc length is the entire part of this here. So all the way up to the center of the circle, this entire area is the sector of the circle. So that's the difference between those two. So to find the area of a sector of a circle, I'm going to be using this formula here. A equals 1/2 r squared times theta. Again, we have r is our radius of our circle, theta is our central angle, and it has to be in radians, and then A is going to be my area. So to solve for the area of a sector, it's pretty much the same steps. First step, make sure your angle measure is in radians, always in radians, and convert it if you have to. Then go ahead, plug in your radius and the central angle measure, which is theta, and then you can calculate the area, and again, round to the nearest tenth. So for this example, I am given a central angle, so let me write out our formula first. A equals 1/2 r squared times theta. So I'm given my central angle of 225 degrees. That is not in radians, so the first thing we have to do is convert that to radians. So I have 225 times pi over 180. And when I multiply that, I get 225 pi over 180. And then when you go ahead and reduce that, 225 over 180 actually reduces to 5 pi over 4. So that's 225 degrees in radians. Next step is just go ahead and plug it into the formula. So I'm solving for this area. So A equals 1/2 times my radius. My radius is 8 centimeters, so 8 squared, and then times theta, which we just found in radians is 5 pi over 4. Now I just need to go ahead and do all the math. So I get that A equals 1/2 times 64 is 8 squared times 5 pi over 4. So then I get that my area is 1/2 times 64 is 32 times 5 pi over 4, which equals 32 times 5 is 160. So 160 pi over 4. And so then we get 160 divided by 4 is actually 40. So we get that the area is 40 pi. So then my last step, again, take that, and I want to round to the nearest tenth. So 40 times pi is approximately 125.7 because I get 0.66 and I want to round up to 7. Now, when I'm labeling my area, remember when I'm working with area, my units are always squared, okay? So the area of this circle is approximately 125.7 centimeters